So this is the 2016 Junior Cert Higher Level Paper 1 and we're looking at question number 10. The graph of the function y equals f of x is shown on the coordinate diagram below. For x is between -3 and 3 inclusive, where x is an element of the real set. The graph is made up of two line segments, so we can see the graph here at y equals f of x, 2 line segments. Okay, the question says fill in the table below to show the value of f of x and the value of f of x minus 2 for each of the given values of x. Okay, so when x is minus 3, here we can see that f of x is, this value of f of x is minus 2. And when we're at minus 2 on the x-axis, f of x is 0. When we're at minus 1 on the x-axis, we have to go up to 2 on the f of x-axis. When we're at 0 on the x-axis, we have to go up to 4 on the f of x-axis. The f of x-axis is also just the y-axis. When we go over to 1 on the x-axis, we're going up again to 2 on the y-axis, or 2 on the f of x-axis. When we go over to 2, we're on the function, so it's 0 on the f of x or the y-axis. And finally, when we're going over to 3 on the x-axis, we have to go down to here, which is minus 2 on the f of x-axis. Okay, so then we're asked to fill in the table for f of x minus 2. So we're just, if these are the f of x values, and we want the f of x minus 2 values, we're just going to subtract 2 from each number here. So this number subtract 2 is minus 4. 0 subtract 2 is minus 2. 2 subtract 2 is 0. 4 subtract 2 is 2. 2 subtract 0 is 0. Sorry, 2 subtract 2 is 0. 0 subtract 2 is minus 2. And minus 2 subtract 2 is minus 4. So now we've completed the table. Part 2 says, hence or otherwise draw the graph of y is equal to f of x minus 2 on the coordinate diagram above in the same domain, minus 3 to 3. So now we're just going to plot those points. So the graph of f of x minus 2 would be, when x is minus 3, the graph would be at minus 4. So it would be this point. Then we'd have minus 2, minus 2, minus 2. Then we'd have minus 1, 0, minus 1, 0. Then we would have 0, 2. 0, 2 would be here. Then we would have 1, 0, so over to 1 and then 0. Then we'd have 2, minus 2, so 2, minus 2. And finally we would have 3, minus 4, so over to 3 and down to minus 4. So we just need to join those points up. The first line will be there, and then the second line would be there. And that would be the function y is equal to f of x minus 2. So part B says the graph of a different function, y is equal to h of x, is shown on the coordinate diagram below, for x being in the domain minus 3 to 3 inclusive, where x is a real number. The graph is made up of two line segments again. So we can see the graph here. There it is, y is equal to h of x. And we are asked, fill in the table below to show the value of h of x for each of the given values of x. Okay, so again, if we're at minus 3, you can see we have to go up to 2 to hit the function. So if we're at x is equal to minus 2, we have to go up to 1. The h of x. If we are at minus 1, it's at 0. At 0 we have to go down to minus 1. If we're at 1, again it's 0. Over to 2 we got to go up to 1 again. And finally all the way over to 3 we got to go up to the number 2. So there's our h of x values. Part 2 says, hence or otherwise, draw the graph of y is equal to h of x all to be squared on the coordinate diagram above, again in the domain, same domain. So we're looking for y is equal to h of x all squared. Okay, so the easiest way to do this would be to add another column. So if we're going to add the column, we're looking for h of x all to be squared. That's this column here. So we got to square each of these h of x values. So that will give us 4. 1 squared is 1. 0 squared is 0. Minus 1 all squared is 1 again. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So they asked us then to draw that graph. So we're going to plot that graph here. So when x is minus 3, h of x squared is 4. So we're going to go minus 3, 4, that's 1 point. Then we've got minus 2, 1, so minus 2, 1. That's another point on the curve. Then we're going to have minus 1, 0, so minus 1, 0. Then we will have 0, 1, so 0, 1. Then we're going to have 1, 0, so 1, 0. Then 2, 1, so over to 2, up to 1. And finally, 3, 4. So again, this is going to be 3, over to 3 and up to 4. So we can see this graph is not linear, it's not straight lines, so we're going to have to join these up with a smooth curve. So we're going down here, we hit the 1, we turn back up, hit the 1 here, and then again we're going down to hit this 1, back up through this point, and finally up to there. So we get a kind of a double curve here for that graph. And that's the end of question number 10.